Okay, so on page 533, these are systems of equations that are not linear, meaning they have powers that are bigger than just 1. So we have x squareds and different things going on with them. So this first problem, it says solve for x and y using substitution. So I am going to look at this and I see, oh, there's y equals already set up for me. So I'm going to take this and plug it in for that y on the other equation. Okay, because it's all nice and set up, just waiting for me to do something like that to it. So I have 2x minus parentheses x squared minus 2 equals 2. So I distribute that negative in there, so I have negative, or 2x minus x squared plus 2 equals 2. So now I want to get it equal to 0. Anytime you have a squared and a single power, it's quadratic, and so you want to get it equal to 0 so that you can factor or use the quadratic formula. So I'm going to minus that 2 over there. So I now have negative x squared plus 2x, 2 minus 2 is 0, equals 0. So, oh, it's working out better. I can factor this. Hopefully you're remembering how to factor. So each of these have an x in common. So I pull out an x. That didn't show up. So I pull out an x from them, and I get negative x plus 2. So now that I've got it factored, remember you can just put each factor equal to 0. So there's my first answer is x equals 0. Negative x plus 2 equals 0, so I just minus the 2 over, or add the x. A negative x equals a negative 2, so if a negative x equals a negative 2, a positive x equals a positive 2. Because really you just multiplied everything by negative 1, or multiplied the left side, and what you did to the left, you did to the right. So x equals 2. Now, our y values depend on our x. So I'm going to plug the x back into here. So y equals 0 squared minus 2, which is negative 2. So when x is 0, y is negative 2. So now I have y equals 2 squared minus 2 because I plugged the 2 in for the x. Remember that x is what we're plugging our value that we just solved for down here. So 2 squared is 4, minus 2 is 2. So when x is 2, y is also 2. And that's my answer. So my two solutions to this problem are those. So now moving on to the next question. Again, we're still using substitution. So I'm going to have to solve for y down here. So I minus the x from each side, or I could have solved for x. I'm used to solving for y, so I did. So y equals negative x plus 1, plus I'll show you why I solve for y when I go to the graph part. Okay, so now I'm going to replace this y up here with negative x plus 1. So I have x squared plus parentheses negative x plus 1, and it is still squared because this y was squared. So I replaced this y with the value from down here, but I must still square it. That equals 25. Now remember, when I square it, what I really have is I have negative x plus 1 written out twice. Okay? So you have to make sure you distribute that. So negative x times a negative x is a positive x squared. Negative x times 1 is negative x. 1 times negative x is negative x. 1 times 1 is 1. So I have x squared minus 2x plus 1. That's what this part is now. So I really have x squared plus all of this stuff, which is x squared minus 2x plus 1, equals 25. So we want to make it equal to 0 now. So anytime we have an x squared and an x, we want to make it equal to 0. So I minus the 25 over here, minus 25 over. 1x and 1x squared and 1x squared makes 2x squared. Minus 2x minus 24 equals 0. And I see that those are all divisible by 2. So to make life easier, I am going to divide all of these by 2. So now I have x squared minus x minus 12 equals 0. And so that should be a much easier factoring process because I know that the only things that multiply by x squared is x and x. Now I just have to say, what multiplies by negative 12? Well, negative 12 is negative 1 and 12, or vice versa. 2 and negative 6 and 3 and negative 4. But they have to add to be negative 1 because that's my middle term. So the only one of these that add to be negative 1 is 3, negative 4. So plus 3 minus 4. So that multiplies to be negative 12 and adds to be negative 1. I now have it factored, so I set each of these equal to 0. So now I minus the 3, x equals negative 3, add the 4, and x equals 4. But now I need to figure out what y is, and remember y equals negative x plus 1. So now I just plug that negative 3 in there. So negative 3 is being in for the x. So minus a minus turns into a plus. So I get y equals 4. So that negative moved to there. Negative 3 was already there. So when x is negative 3, y is 4. X equals 4. Well, what does y equal? Y equals negative x plus 1. So negative 4 plus 1 is negative 3. So when x is 4, y equals negative 3. And those are my solutions. Now, to do this graphically, you just have to do it freehand. If you remember, anytime you have a number squared plus a number squared, if they have the same coefficient, which is a 1, I have something squared plus something squared equals a number, it's a circle with the center at 0, 0 because there's nothing in those. So I have a circle with a radius of 5 because, remember, the radius is the square root of that number at the end. So the square root of 25 is 5. So the square root of 25 is 5. So my circle is at 0, 0 with a radius of 5. Whoops. Whoops. Anyways, you get the idea. That's supposed to be a circle. Now when I go to graph this, I start at positive 1. I go down 1 over 1, continue my process. And where does it intersect? The line intersect the circle? 1, 2, 3, 4, 4. Well, that's supposed to be at a negative 3. So that's why we do it algebraically. If we don't have nice, good tools to draw with, then it's better to do it algebraically. So, anyways, if you want to see it real fast, I can try to make it real fast. That's a bad color. So then we started at 1, went down 1 over 1, so it's this line right here. Then our circle, centered at 0, radius of 5. That's not a very good color. Not sure why it did it that color. Anyways, you can kind of get the idea on this, even though the colors aren't the greatest. That's a little bit better. And so now I can see the x is 4, the y is 3. Over here the x is negative 3, the y is 4. And that's where those intersect. That'll hurt your eyes. Try to pick that number out of there. So anyways, that's the way to do it algebraically on the page before, graphically here. Now number 7 still says to use substitution, so I'm just going to plug the square root of x in for y. So I have x squared plus the square root of x, all being squared, equals 20. Nice thing about this, squared and square root, they cancel each other off, so I just have x squared plus x equals 20. So now I'm going to make it equal to 0, so I have x squared plus x minus 20 equals 0. I minus 20 from each side. So now that I have this, you should be thinking in your head, oh yeah, that factor is the only thing that multiplies to be x squared is x times x multiplies to be 20, negative 1 and 20, negative 2 and 10, negative 5 and 4. But it has to add to be positive 1. So these don't work, but 5 times negative 4 multiplies to be negative 20, and 5 plus negative 4 adds to be 1. So there we go, plus 5 minus 4 equals 0. So that multiplies to be negative 20, adds to be 1. I put each of those equal to 0. I get that x equals negative 5 and x equals 4. But now we have to figure out what y is, so I plug this back in for y. So y equals the square root of negative 5. Well, that's no good. We can't have an imaginary number under here because we only want real solutions right now. So we just say that one didn't work. And now on this one, we have the square root of 4. So y equals the square root of 4. The square root of 4 is 2. So when x is 4, y equals 2. Okay, you could have tried to do this one graphically, but realize the square root of 20 is like 4.6 or something. And then you've got to do the square root of x, which is like this, and hope that you're matching up at 4 and 2. So if you have a way to graph a circle really well, you could do that, but it's kind of tough to pick where 4.6 is exactly and make it go around in a circle. So that's why we do it algebraically. So number 15 says use elimination. I'm looking at this. Nothing. Elimination is when you add them together and you get something to go away. Nothing, if I add these together, will go away. So I'm going to say let's get rid of the x's. So I'm just going to multiply all this by negative 2. So now what I get is negative 2x squared minus 8y squared equals negative 16. The biggest thing is make sure you distribute that negative 2 to everything. So I've done that. So now I can combine it. Realize when I say combine, what I really mean is we're going to add these two equations together. Okay, so 2x squared minus 2x squared, those go away. Negative 8y plus 3y is negative 5y squared. Negative 16 and 11 make negative 5. Well, I'm going to divide each side by negative 5 because I want to try to get this y squared alone, and there's no other y, so I don't have to try to factor. And I also saw that they're both divisible by negative 5, so that'll make life easier. So I have y squared equals negative 5 divided by negative 5 is 1. So now to get rid of a squared, I can just square root it. So y equals plus or minus 1. So now that I know what y is, I'm going to plug it back in so we can figure out what x is. So x squared plus 4 times 1 squared equals 8. So x squared, 1 squared is still 4, plus 4 equals 8. Minus the 4, minus the 4, so I get x squared equals 4. Take the square root, and I get that x equals plus or minus 2. So that was plugging in a positive 1. So when I plug in 1, I get out a 2, and I get out a negative 2. So I get two answers from that 1. So now I'm going to plug in negative 1. So I get x squared plus 4 times negative 1 squared equals 8. Well, negative 1 squared is still a negative times a negative is a positive. So now I'm to the same boat as I was before. X squared plus 4 equals 8. So really I know that x squared equals 4, and that's going to equal plus or minus 2 because, you know, we just did that over here. Square root here, square root here. So when x is negative 1, I get two different answers. 2 and negative 2 again. So on this problem, I ended up with 4 answers. Okay? So you could graph these. The best way to graph these is really to type it in Desmos, and then you could see what these are. These are both ellipses. It's really not the easiest ellipse to graph by hand, but Desmos would do it for you to check your work. Number 17, it says use elimination again. Rather than getting rid of my x squareds and having to work with xy, I'm going to get rid of this xy so I can just deal with one variable. I'd rather not have two variables, so I'm going to just multiply all of this by 3. So that gives me 3x squared minus 3xy equals 60. So now I have negative 2x squared plus 3xy equals negative 44. That was my original equation. So now when I add these two equations together, so we're going to add these two equations together, we combine them. 3 minus 2 is 1. My xy's go away. 60 minus 44 is 16. Take the square root of each side. X equals plus or minus 4. So I now know what x equals. So I'm going to pick one of these. This one has smaller numbers, so I have x squared minus xy equals 20. So I'm going to plug positive 4 in for my x. So I have 4 squared minus 4 times y equals 20. Well, 4 squared is 16. Minus 4y equals 20. Minus the 16 from each side. Negative 4y equals 4. Divide it by negative 4. And y equals negative 1. So an x was positive 4. Y is negative 1. That's one solution. Now I need to do negative 4. So I'm going to have negative 4 squared minus x, which is negative 4, times y equals 20. Well, negative 4 squared is 16. A negative and negative 4 make a positive 4y equals 20. So minus the 16 over to each side, and I have 4y equals 4. Divide it by 4, and I get that y equals 1. So when x is negative 4, y is a positive 1. So those are my two solutions. You could plug these back in, both of them into both equations, and find out if they work. It has to work in both equations, not just one, or else it doesn't work. So that's how you do that problem. The next one that I'm going to work out for you is 21. It says use elimination on this. So I see right now that I have x squared and y squared on the same side, but not on this one. So I'm going to add this y squared over to here. So now what I have is x squared plus y squared equals 1. And I still have 9x squared minus 4y squared equals 36. So I'm going to multiply that all by a negative 4. That's going to get rid of my y squares when I add these two equations together. So now I'm going to write that original equation that I began with, 9x squared minus 4y squared equals 36. So now when I combine those, my y squareds go away. 9 minus 4 is 5. 36 minus 4 is 32. So this is kind of a mess. Divide it by 5, and x squared equals 32 fifths. For the sake of what we're after, we're going to solve this for y. So I get x equals plus or minus the square root of 32 over 5, and then we could take out 32 is 16 and 2, so that's 4 and 4. So there's a pair of 4. So what I really have is plus or minus 4 square roots of 2 and square roots of 5 on the bottom. And then because we don't like to leave a square root on the bottom, I can multiply top and bottom by the square root of 5. So what I get is really 4 square roots of 10 over 5. Plus or minus. Okay? But this part's an important part because it says x squared equals 32 fifths. So I can replace this x squared right here with 32 fifths plus y squared over 1 equals 1. So 1 is 5 fifths, right? That's the same. 1 is 5 fifths. So now I minus 32 fifths over. And I get that y squared equals negative 27 fifths. And when I take the square root of that, I end up with this negative under here, which is not good. There's no real solutions. And we're done with that problem. Okay? Graphically, if I look at this, x squared plus y squared equals 1. That's a circle with a radius of 1. So there's my circle. Now this one is like an ellipse. It's not quite an ellipse. It's called a hyperbola. The reason you know it's a hyperbola, I still have an x squared and a y squared, but instead of being like an ellipse, it's a plus between these. A hyperbola is a minus between them. 9 over 36, 36 divided by 9 is 4, so that's the same as x squared over 4. 36 divided by 4 is 9, so that's y squared over 9 equals 1. So this has a center at 0, 0. So 0, 0. The x direction, I go the square root of 4, which is 2, so I go 1, 2 on the x direction. The y, square roots of 9 is 3, so I go 3 in the y direction. Now if it were an ellipse, you'd connect these. And even if we did that, they would never intersect. But since it's a hyperbola, what you do is you make a little rectangle. You connect your diagonals. And then since x squared is the one positive, you kind of go here, and those are asymptotes, and it goes like this. So hyperbola is like, think of an ellipse. It's like these arms are running towards each other, and it forms, hyperbola, it's like they're running away from each other, and they're never going to touch. But I don't know, however you want to think of it. You can see that this line out here never touches this circle. So there's no intersection point, so that's why there are no real solutions. Okay, you'll see it in the back of the book written like this, meaning that there's the empty set. There's nothing in there. They never cross. There's no solutions. Okay. So 27, it says use whatever method you'd like. Well, I have options. I could use, the easiest thing really is, since this was y equals and y equals, is I'm going to replace y up here with what y is. So I have y over x equals x squared. So now, to get rid of that divide by x, I'm just going to multiply each side by x. So I have 1 equals x cubed. To get rid of a cubed, I cube root it. The cube root of positive 1 is just 1. So x equals 1, so I plug 1 in there, y equals 1. And that's the answer. Okay. Now on 25, I wrote that up there because it's going to be the same thing. You're going to replace this y with 4x plus 5. And I'm not going to do all of it for you. And then since I have x squared on one side and numbers on the other, you're going to try to get it equal to 0. And then finish solving from here. Okay, and you get that x squared is 0, so x equals 0. You have to plug that back in and figure out what y is. So anyways, that's kind of a help on 25. I did a lot more than I was going to. 33. I wanted to show you this one graphically first. So remember what I said about if it's a plus between these? Well, that means that it is an ellipse. Okay? So the square root of 4 is 2. The square root of 16 is 4. The center is at 0, 0 because there's nothing here. Normally you would have some number in here, some number h, some number k. Whoops, that should be a minus. And it's always backwards of the signs for the center. So if I had like x plus 3, that would be negative 3 in the x direction, and y minus 4 would be a positive 4 in the y direction. Okay, so it's always backwards of those signs. The center would be at negative 3, 4. So you'd come over here, negative 3 and up 4 and put a dot. Well, this one just has x squared and y squared, so the dot's at 0. The x direction, I'm going to go 2 because this is with the x. So I go right 2 and I go left 2. The y direction, I go 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now I connect my dots. It's going to be an ellipse, that flattened football, a squished egg. I don't know what you want to call it. But anyways, so that's my picture. It's not the best picture ever that I've made in the world, but it'll do. Now in this one, if I solve for y, I get y equals negative x squared plus 4. Well, you can type that in your calculator. You can also realize that that's a parabola. It's gone up 4 and it's flipped upside down, so it goes upside down. So I go negative 4, then 1. When I plug in 2 for x, 2 squared is 4, minus 4 is 0, so it's going to be right here, but then it's symmetrical. So it crosses right here. So there's one intersection point at 0, 4. It meets again here at 2, 0, and it meets again over here at negative 2, 0. So those are my intersection points, and those are my answers to this problem. Okay, so that's how you could do that problem graphically. So now, to do it algebraically, I'm going to solve this for y. Y equals negative x squared plus 4, and I'm going to plug it up into here. Maybe I'll solve for x squared. X squared equals 4 minus y. That seems a little bit easier. Now I'm going to replace this x squared with 4 minus y. So I have 4 minus y over 4 plus y squared over 16 equals 1. So remember, we really don't like to have fractions when we're working out these problems. So I am going to multiply the whole thing by 16 or get common denominators, which is 16. So I'm going to multiply this one by 4, multiply this by 16, and now I have common denominators. I can get rid of the denominators. So 4 times 4 is 16. 4 times negative y is negative 4y plus y squared equals 16. I'm going to minus the 16 from each side. So y squared minus 4y equals 0. So that's nice. I factor out a y, I get y minus 4 equals 0. So I have y equals 0 and y equals 4. Because I had y minus 4 equals 0, so I added the 4 to each side. So y equals 4. So that's how I got those two answers. So y equals 0, y equals 4. Well, I'm going to plug that back in for this right here to figure out what x is. So I know that x squared equals 4 minus y. So x squared equals 4 minus 0. So x squared equals 4. Take the square root. X equals plus or minus 2. So when I plugged in 0, I got two answers. So I got 0 and 2 and 0 and negative 2. Now I'm going to plug in 4. So x squared equals 4 minus 4. Well, 4 minus 4 is 0. The square root of 0 is still 0, so x equals 0. So when y is 0, x is 0. And notice it's the same three answers as I got when I graphed it. Okay? So anyways, two different ways to do that problem. Sometimes graphing works out nice, sometimes it doesn't. It's great if you can remember how to do it. It's tough if you can't remember. So anyways, that's some help on this page and on those problems that you need to work on. So carry on, good luck. If you get stumped, I can set up a Google chat with you, and I can talk with you as I work out a problem, and you can talk to me and stuff like that. So whatever you need to do, and good luck on this.